Hello, my dear students. Welcome back. Last class we discussed SN1 mechanism. In SN1 mechanism takes place in tertiary alkyl halides. That is nothing but bulky alkyl halide. Whereas reaction mechanism takes place through carbocation. Rearrangement is possible. If alkyl halide is chiral, we'll get racemic mixture. But inversion dominates. Inversion dominates over retention. So these are the points we discussed. And most important point, polar protic solvent. Polar protic solvent favors SN1 mechanism. Now look at the very important question. Which of the following can show partial racemization is the question. Already we discussed. If chiral carbon is there, we'll get racemization. A tetrahedral center attached with 4 different groups. Here all the phenyl groups are same, therefore it does not form racemic mixture. Here also we can see the similar methyl groups. All the methyl groups are same. Here we have 2 phenyl groups same. No chiral center. But this is a chiral center. Methyl, hydrogen, phenyl. Therefore this is a chiral center. Therefore this will form racemization. The means substrate has one chiral center will show. Substrate has one chiral center shows racemization. If chiral center is not present, then there is no racemization. This is very important. Let us move to the SN2 mechanism. Already we discussed what is SN2, dear. Bimolecular nucleophilic substitution reaction. SN2 mechanism generally takes place in primary alkyl halides. And mechanism takes place in single step. Mechanism takes place in single step. That is, nucleophile will attack from the back side because we are taking simple alkyl halide. Therefore, very difficult to break carbon halogen bond. Nucleophile will attack from the back side. We are getting a transition state. Transition state. Transition state is observed in the case of SN2 mechanism. Carbocation SN1, transition state SN2. So it is a slow step and rate determining step. Therefore, rate is directly proportional to concentration of alkyl halide as well as nucleophile. Therefore, it is an example of second order reaction. Example of second order reaction. In rate determining step, alkyl halide as well as nucleophile both are participating. Therefore, it is an example of bimolecular reaction. Bimolecular reaction. Rate is dependent on the concentration of nucleophile. Rate is dependent on the concentration of nucleophile. So, very important point you need to remember. Transition state, hybridization is going to be sp2. No carbocation. No carbocation. Hence no rearrangement. No carbocation, no rearrangement. We required strong nucleophile. Strong nucleophile. And very important, polar aprotic solvent. Polar aprotic solvent like acetone, DMSO, dimethyl sulfoxide, dimethyl formamide, etc. favors SN2 mechanism. Transition state, rate directly proportional to concentration of alkyl halide and nucleophile second order. Bimolecular reaction, transition state is observed, no carbocation, no rearrangement, polar aprotic solvent. Polar aprotic solvent like DMSO, DMF will favor SN2 mechanism. Stereochemistry, if you observe, you can check this chiral carbon, hydrogen, deuterium, alkyl group. So chiral center is present means we'll get Walden inversion. Walden inversion will get. Sir, what do you mean by Walden inversion? Walden inversion is nothing but if alkyl halide is D, here we'll get L. If it is L, we'll get D. If it is R, we'll get S. If it is S, we are getting R. Reverse configuration will observe. Therefore, it is called Walden inversion, and it is 100% inversion product. Very, very important. 100% inversion product. So next one, reactivity towards SN2. Reactivity towards SN2. Methyl, ethyl, and secondary and tertiary. So I can say simply methyl followed by primary, followed by secondary, followed by tertiary. In secondary, as the branches increases, reactivity will decreases. So you can see here, this is primary, this will be primary, this will be primary, but branching at beta position, this will be alpha, this will be beta, this will be beta with respect to halogen. Here we have one branch, here we have one and two branches. Branches at beta position decreases rate of SN2. Therefore, this will be more reactive than this. Very, very important. So now, very, very important, Nana. Already we discussed in the case of SN2 as well as SN1. Allyl and benzyl halide undergoes both SN1 as well as SN2. Allyl as well as benzyl will undergo both SN1 and SN2. You have to remember. You have to remember. This is very, very important, dear. Next, at beta position, if carbonyl group is there, at beta position carbonyl group increases rate of SN2, that is electron withdrawing group increases rate of SN2. These 2 points are very, very important points. The first point, allyl, benzyl will show both SN1 as well as SN2. Whereas second important point is at beta position carbonyl group is there, which will increases rate of SN2. Very, very important. So finally, let us discuss one more important point. SN2 reaction does not takes place if halogen is attached to sp2, that is vinyl, tertiary alkyl halides, aryl halides, that is halogen attached to sp2, neopentyl halide. This is, even though it is primary, because of steric hindrance, it does not undergo SN2 mechanism. SN1 as well as SN2 does not takes place if halogen is attached to sp2 hybridized carbon. So finally, primary alkyl halide will undergo SN2 mechanism. Secondary alkyl halides will undergo both SN1 as well as SN2 if it is polar protic solvent SN1. Polar aprotic solvent, it is going to be SN2. In the case of tertiary alkyl halide, SN1 mechanism takes place. So this is majorly the SN1, SN2. SN1 tertiary alkyl halides. Two steps mechanism. Carbocation. Racemic mixture will form, but inversion will dominate. Polar protic solvent. SN2 primary alkyl halides. One step mechanism. Transition state. Polar aprotic solvent will favor SN2 mechanism. Thank you, dear. Please like and subscribe and share. Thank you.